All right, let's get right into it. Today, we're talking about that invisible force you work with every single day. The power that runs your plant is obviously essential, but it demands, and I mean demands, your full attention and respect. Let's dive in.
So, I want you to just take a second and really think about that. Right now, all around you, from the control room you're sitting in to the furthest pump out on the pad, what is the one thing that connects it all? It's not a trick question, I promise. The answer is something we honestly take for granted way too often. You got it. It's electricity. Seems simple, right? But here's the thing. It's an incredibly powerful, totally invisible force. And the main idea we're going to talk about today, the thing I really want you to take away from all this, is that this force demands your respect. Every single minute of every single shift. To really respect it, we've got to first understand just how vital it is. So let's stop thinking of the electrical system as just another utility and start thinking of it as the very heartbeat of your entire facility. I mean, this slide really lays out the fundamental truth, doesn't it? Every single thing that happens in the plant, every motor that turns, every pump that moves product, every compressor that builds pressure, and yeah, every control that keeps the whole process safe, it all starts with electricity. Let's be real, without power, there's no production, and way more importantly, there is no safety. It is that simple.
Okay, so where does all this power actually come from? And how does it get to the equipment you operate every day? Let's trace its path for a minute. We're going to decode the flow, from the outside world right to your machine. Before we follow that path, let's just get two basic terms straight. And trust me, this analogy makes it super clear. Think of voltage as the push. It's the pressure behind the electricity. Then you have current, which is the actual flow, the amount of electricity that's moving. You absolutely need both, pressure and flow, to get any real work done. That's it. No complex physics, just remember pressure and flow. So here's that journey we were talking about. It all starts way out there at the massive utility grid. Then it gets to your site, and transformers step that super high voltage down to levels we can actually use. From there, it goes to the switchgear. Think of that like the main breaker panel for the entire plant. And finally, it gets routed to the motor control centers, or MCCs, which are basically the local hubs that send the right amount of power to your specific motors and pumps. See, it's a clear, logical, step-by-step flow. Okay, so we get the what and the how. Now let's shift gears to the most critical part of this whole explainer, how you stay safe around this stuff. The dangers are invisible, which means the rules, well, they have to be visible and followed without a single exception. And let's be perfectly, brutally honest about the stakes here. An electric shock isn't some funny zap you see in the cartoons. It can stop your heart, instantly. An arc flash isn't just a bright light, it's an electrical explosion. I'm talking a violent blast of plasma with unbelievable temperatures and force. And of course, you've got fire risk from overheating or bad equipment. These hazards are real, they are silent, and they are absolutely deadly. So the crucial thing here is knowing your role. This is your code, your playbook. The do's are simple, right? Read and obey the signs. They are there for a reason, to protect you. Keep those panels closed and latched. That contains the danger. And if you see, hear, or smell anything weird, a buzzing sound, a strange smell, a panel that feels hot, report it immediately. Now the don'ts. These are absolute, non-negotiable. Never, ever bypass a safety interlock. It might feel like a shortcut, but you're literally disabling something designed to save your life. And never, ever open an energized electrical panel. Period. And that brings us to what might be the single most important sentence you'll hear today. Read it, memorize it, live by it. Your job is to operate the equipment. An electrician's job is to work on the electrical system. Knowing that difference and respecting that boundary, that is what keeps you safe. Your expertise is in running the process. Okay, now let's apply all this to a real-world scenario that can and does happen. A power disturbance or a full blackout, that's not the time for panic. It's a time for professionalism. You are the first responder for the process side of things. So picture it. That familiar hum of the plant just goes away. It gets dark. It gets quiet. What is the very first thing you do? Your instincts might be screaming to do a dozen things at once, but there is a clear, professional way to handle this. And here it is. Step 1. Before you do anything else, stay calm. Panic causes mistakes every time. Your calm, professional response sets the tone for everybody else. Step 2. Secure your critical equipment, just like you were trained to do. And finally, step 3. Follow your plant's specific blackout and recovery procedure to the letter. Every plant has one. You need to know it. Procedures are what prevent chaos and make sure there's a safe, orderly recovery.
We're going to end on this because it's something you can't ever forget. Unlike a lot of things in life, with a serious electrical incident, there are no do-overs. There are no second chances. So respect the power, know your role, and follow the rules. That is how you protect yourself, your team, and your plant.